All right. Good morning, everyone here live in South Korea, and good morning, afternoon, or evening to everyone watching on the live stream or watching the live stream after. Today, I'm going to give a workshop on IBC, how to get started with it. But first, a little bit about myself. I am Thomas Dekeyser. I work as an IBC DevRels at Interchain GmbH. Started doing that in February this year, so only like 6 months. So pretty new to the ecosystem, but very excited about interoperability in IBC, and hopefully I can share some of that excitement with you today. So before we start the workshop, let's look at the goals of the workshop. So what we'll be doing today is first and foremost get a high-level understanding of IBC to make sure that you can go and visit the docs yourself and know where to go and how to read them and follow and understand them. Then we also have the demo itself from the workshop. I already sent the people who are here a link. We'll see the link in a minute for those watching via the live stream. So for the workshop, if you feel comfortable following along with the commands, that's perfectly fine. If you're not and you don't want to multitask, you can just follow along with me. The most important thing is that you follow and understand what I'm doing rather than simply like copy-pasting the commands so that you can do it on your own yourself later. Another important point that I want to mention is that in the Cosmos ecosystem, like, development is always ongoing. So I think it's kind of important that you learn to manage different versions of the software, and in this particular case on the IBC demo, the relayer software. And this is particularly important because right now we are actually at a time when both major relayers, the Golang relayer and the Hermes relayer, are going to have a new major release soon. V2 for the Golang relayer, V1 for the Hermes relayer. So the versions that are specified in the demo, you can use them, and then everything should work fine. But feel free, if you revisit the demo at a later time, to try it out with your own version that is the latest at this time. And I think it's also important to look at what we're not going to do in this workshop. IBC is, the Inter Blockchain protocol, so you need 2 blockchains running to work with IBC. But it's out of the scope of this workshop to really look at how you build your own chains or your modules. We're not going to look too deeply at the code. And also custom configuration of your chain configs and the Genesis files. This is not something that we'll handle in this demo. You can, of course, always visit the docs or look at other workshops or the documentation. All right, so hopefully I will get your attention after this talk. And if you want to go further along the path of developing in Cosmos with IBC or with the Cosmos SDK or with Tendermint, I want to promote a little bit the Interchain Academy, Interchain Developer Academy, that is. So this is essentially a program that we started in collaboration with B9 Labs that wants to train it is 5,000 developers in the next 3 years, and this is free of cost. So this is a program that is self-paced, 6 weeks, and the intention is to train Web 2 developers into Web 3 developers or blockchain developers, because we believe we need a lot of people to join us to make sure that we get the Cosmos ecosystem flourishing. So there are some next cohorts starting in September and December. So what you will be doing there is you will be building with the Cosmos SDK. You will also learn about Ignite CLI. You will learn about Cosmos.js to build your interfaces. You will learn how to run a validator node. And finally, you will also learn to run a relayer that enables IBC. And the idea is that if you follow this program, and you finish it, you might get a better chance of getting hired at one of the core contributors in Cosmos. So actually the content that you have in the Interchain Developer Academy is exactly the same as the one that you will have in the Cosmos Developer Portal, so you can follow that with the link that is over there. It's tutorials.cosmos.network. So once again, we have all of the content that is there on the SDK, Ignite CLI, IBC, and Cosm.js. We have some tutorials there, blog posts, and it's continuously in development. An important point is that probably if you're new to Cosmos and you're new to developing with the Cosmos stack, you might first want to go to the Cosmos developer portal, and this will make you ready to then go into the GitHub repos and into the documentation on your own. All right, so now about IBC. I think it's always important when you start learning about something new that you understand why you're doing it. And so IBC, as you can see, is the Interchain's universal general purpose interoperability protocol. And when you think about why do I use IBC, I think it kind of like splits into two parts. The first one is why do we want to use interoperability in the first place? And I think it's pretty clear at the state of blockchain industry right now that we won't have like one chain to rule them all, and that interoperability is actually quite important. A little anecdote for myself, I wanted to get into blockchain development since a long time already, I think 2017, 2018. And I didn't have any development experience back then, so I was really like looking at all the different languages, all the different ecosystems, and I found it quite hard to pick my particular ecosystem, because I thought like back then there was no interoperability, or at least less. I mean, Cosmos was there, but mainnet hadn't been launched. And so a choice for one particular ecosystem would be like quite a big choice in terms of energy and investment. And I think interoperability really helps the developers here, because if you build an application, you know that through interoperability, this application might be spreading out to all of the other ecosystems, and yeah, your application might be used to the full extent. Now the second thing is, why would we pick IBC over competitors? Competitors, for example, being simple token bridges that use some multisig. Well, it's because IBC is secure. It works with a light client mechanism that we will look into a little bit more detail later. So basically, we don't need to trust the middleman, which in this case is the relayer. So we have two blockchains, and in between we have the relayer. We don't actually have to trust the relayer. Anyone can spin it up, and we're actually going to do that in this workshop. And we don't have to trust the relayer to make sure that yeah, our assets are secure. And so this is the permissionless aspect. And third, IBC also supports generalized message passing. So it's not just that we're able to send tokens from one chain to another, it's really that we can send any packet of arbitrary data over the relayer from chain A to chain B. All right, so this is a diagram about the Cosmos stack. Maybe many of you are already familiar with it, but still it's good to have a resume. So we have the Cosmos SDK, Tendermint Consensus core, and IBC. So Tendermint Consensus is at the bottom, so it takes care of the consensus and networking layer. Then we have the Cosmos SDK, which is the application building layer. And then we have IBC that takes care of interoperability. So right now in IBC, I think this may be already a little bit outdated. 45 chains are connected and some additional data. And even though IBC originated from the Cosmos stack, it's important to realize that it's not like limited to the Cosmos ecosystem. So we really have the aim of expanding IBC really to pretty much any chain that is out there. And some of the projects that you see there, Composable Finance has been working on bringing IBC to substrate-based chains, so in the Polkadot ecosystem, and this is almost finished. And then we also have the Near blockchain, which they are building a bridge towards. All right, so a first slide of IBC. I think you can look at the diagram first. So there we have our two blockchains, chain A on the left, chain B on the right. We have multiple relayers in between. So the relayers are the parties that are responsible for transferring the packets over to the other chain. And like we mentioned, this is permissionless. Everyone can simply spin up a relayer. So this is why we have the multiple relayers to really make sure that you understand that it's not just 1 or 2 relayers. Pretty much anyone can do this. And so also in the diagram we see the light client that is over there, but this we will look at in more detail. And what we also see is that we have kind of the split between the IBC TAO, or transportation layer, and TAO stands for transportation, authentication, and ordering. And so what this does is, this is the layer, the core layer, that is responsible for simply making sure that packets can be transported, authenticated, and ordered, if necessary, from one chain to the next. And then on top of that, we have the application layer. And this is really the layer that makes sure that we can encode, decode, and interpret the packets that are being sent. So for the transport layer, the packet data is pretty much opaque. We don't need to know what is in the packet. We just make sure that it gets sent. And then the application layer takes care of the packet data. This is, I guess, the diagram that if you understand it, you probably understand IBC on a high level. Don't be afraid of it. We're going to go through. I'm not sure if you can see my mouse here, but basically the top part of this diagram is the application layer. And most of you will probably be building IBC applications, so this top part is actually the one that you'll be mostly concerned with. So there we have, for example, a user that initiates some kind of transaction on an application. Then it will interact with IBC. And here we see the clients, connections, and the channels. We'll look into that in more detail. We also have some proofs, standardized keypads, and I think here it's very small, but we also have the relayer. And basically, when we have the IBC Go repo, which is the reference implementation of IBC that our team at Interchain maintains, pretty much we take care of all of this. So the clients, the connections, the channels, and everything around it, which is the transport layer, as I said, and then it's up to other developers to develop some applications, even though the IBC Go repo also contains some applications, 2 of which we will see in the workshop later. All right, so as I mentioned, we kind of have like 3 main layers of abstraction inside the IBC protocol. And I'm actually going to go from the bottom up to the top. First, we have clients. So clients track the consensus state of counterparty chains. So we can imagine that if we have 2 blockchains and we want them to communicate, we need to make sure that they understand how to interpret the state of the other blockchain so that they can really know that a packet was indeed sent. And this is what the clients, or the light client, is responsible of. So essentially, when we send a packet on one chain, we will send or submit a commitment proof, and this will be recorded into the state. Then a relayer will construct the packet and add a proof that this was submitted into state, and then submit this on the receiving chain, which can then verify it using the light client of chain A that they have stored on chain B. And important to realize here is also that we have a different light client per consensus type. So like I said, the light client tracks the consensus state of the counterparty chains. So it's kind of logical that if you have a different type of consensus, that you need a different type of light client. And so for a long time, IBC was in fact limited to Cosmos chains, and more particularly to Tendermint consensus type chains, but now with the work that Composable has been doing, we can also go, for example, to Substrate, and hopefully many more will follow. Then on top of clients, we have connections. So connections essentially, establish the connection between 2 blockchains once we have the clients set up. And what happens in the connections is basically kind of a double identity verification. So you must imagine when 2 blockchains want to connect with each other, that they kind of have a picture of the blockchain that they want to connect to, and the other blockchain also has a picture of the blockchain that they expect to connect to. And so what happens in the connection handshake, because both channels and connections will be set up by handshakes, what happens in the handshake is basically we're going to look, okay, are you who you say you are? So is the blockchain that wants to connect to me effectively the blockchain that they pretend to be? And is the picture that they have of me really me? All right, so it's kind of a double identity verification, and if that checks out, we set up the connection, and then we can have the last layer of abstraction, which is channels. And channels also get set up with a handshake, and channels actually identify, in combination with the port, they identify the application. So for example, if we have a fungible token transfer over IBC, this could be transfer slash channel 0, which is the channel. Transfer here would be the port name. So sometimes this is kind of misunderstood. People think a port should be like a number, like 8080, like we have in traditional web development. But in Cosmos development and IBC, it designates like the application. So for example, transfer, or for contracts with CosmWasm, this would be the contract address. And then here we have the base DNAM. An important point is, of course, the relay operators, because if we have two blockchains but no relay operators, then ultimately we cannot do communication. We've mentioned already a few times that relaying is permissionless. It's potentially incentivized. We are actually close to releasing the final version of IBC v4, which will include fee middleware. So fee middleware is an on-chain protocol that allows users to add fees to directly incentivize the relayers. It can be either the end user or chains could decide to do this themselves. Of course, up until now, relayers also got incentivized for the work that they do, but this was happening in a hybrid of ways. And if you click through this Medium blog post, it's called Relaying the Message, a deep dive into IBC relaying operations. We go into a little bit more detail on what relaying is, how you start it, and the different ways that relayers get rewarded. And then this is going to be important for today. So there's different implementations of relayer software. You can use any one of them, and actually in this workshop we will be using two different ones. So we have Hermes, which is written in Rust and developed by Informal Systems. And then we have the Go relayer, which is obviously written in Go, which is developed by Strangelove Ventures. Security is an important value of IBC. So it's good to look at the main two security principles that we have. The first is we need to trust the chains that we connect with. So this is different than, for example, a bridge that has a multisig, so a limited amount of parties that we trust to verify the transactions. In IBC we don't have that. We have the Light client implementation. And ultimately in IBC we assume that the chains that we interact with are trusted, and if that is the case, then IBC will not falter. And the second one is fault isolation. So if anything were to happen, either through some kind of error or misbehavior of any party, if that were to happen, IBC and actually Cosmos as a whole has the idea of fault isolation, so that anything happens to, for example, one particular chain, if you have an interoperable ecosystem, it's quite important that you can isolate the faults and make sure that not the entire interchain will be affected. So for developers and people who want to build a chain with IBC, this is also kind of important. So what is needed to connect your chain with IBC? So first of all, you need to have a chain. This is obvious. But still, if you don't have a chain, so first you can build it, for example, with the Cosmos SDK, or even with Substrate. Now that Substrate can also be connected via IBC. The second thing you need is core IBC, which is a transport layer. As you see below, in IBC, IBC Go, that is, we have the we have this out of the box, the transportation layer, and then we need a light client on our own chain that is able to track the state of the counterparty, and we also need to make sure that the counterparty that we want to connect to also has a light client available that understands the consensus of our chain. And so in the best case scenario, for example, when you're using Cosmos SDK and this has a Tendermint consensus, this will be ready out of the box. If you have another type of consensus or another type of application framework than Cosmos SDK that you're using, it could involve a little bit more development work. And then there's also like an asterisk, which means that they're also like solo machine, which is, as the name implies, just one machine that we can also interact with IBC. And this happens instead of a light client, we have there some simple key verification method that enables you to interact with IBC. All right, so let's take a closer look at an IBC packet lifecycle. So this is the example of ICS20, which is fungible token transfer over IBC. So on the left, we have our tokens that are being locked up on chain A by a user because they want to send over the tokens to chain B. In the middle, we see that after they have been locked up, this packet is indeed being sent. And as I mentioned before, on the chain B, what will happen then is the light client verification algorithm will check if indeed we did this locking up of the tokens on chain A, and if we have verified that this is indeed the case, we can then mint IBC vouchers representing the tokens of chain A on chain B. And this is another way of looking at this. So once again, we have the user here. This is a more generalized packet flow, by the way. So we can do this for tokens, but we can just as easily follow this for a regular packet that has any kind of data. So we have a user that wants to send over a packet. We go to app A. App A gives a send packet command to core IBC. Then we have the relayer who is going to query and see that the send packet has been submitted. So along with the proof, they submit a receive packet on the counterparty chain. When we have the on receive packet, some logic can be executed, and we will also have an acknowledgement that is being written, and then the acknowledgement will follow the opposite way back to the source chain, so that the source chain also knows that the packet has been received on the destination chain. All right, and after this we can, for the first time, go to the demo. So the link is right here. Oops. All right. I hope everyone can see this. So in the demo, we have the overview. Here setup is the installation. So I already sent you guys who are live here in Korea the instructions to install. So this is both the Hermes and Golang relayer. Also the repo itself you can clone. But first, before we start, let's look at what we're actually going to do in this demo. So in this demo, we're going to use two IBC applications. So remember I said we have the transportation layer, which is already finished, and then we have application layers. And the IBC Go repo also includes already ICS20, which is token transfer, and also interchain accounts. And so today what we're going to do is we're going to have two chains. One chain is going to be HackATOM, the other chain is going to be Seoul. Because of interchain accounts, we have, we will see this later, controller and host. And so Seoul will be the host and HackATOM will be the controller. And the first thing we're going to do in the first part is we are going to send over some tokens from the Seoul chain to the HackATOM chain. And then in the second part, when we have interchain accounts, we will delegate some stake from the HackATOM chain to the Seoul chain without actually doing this on the Seoul chain. So we're going to do this from another chain, which is the functionality of Interchain accounts. But that second part will be later. So the first part of the demo will be to send over some tokens from the Seoul chain to the HackATOM chain. I have my terminal set up here. It's a little bit difficult with the mic, but let's see. So first off, what we can do, I'm going to drop the mic for a bit. So yeah, you can first check if the binaries for Hermes and the Golang relayer are installed by simply using the version command. This should probably be fine. Then the next step, what we're going to do is we're going to bootstrap 2 chains and start them in the background. So if we go, for example, to the repo of the code, we see that we have a make file which has all of the different commands. When you scroll all the way to the bottom, those are the commands that we'll mostly be using in the demo. So here you see init that has the kill dev, which basically makes sure that there's no chains running in the background, which can mess up with our program. And we're going to install the binaries. So let's go over and do this. So here we have make init. This will take a little while to set everything up. So here we can see it's installing the binary. The binary here will be ICAD. And you can see that a lot of things have been happening. To get a little bit of a better overview, we're going to take a quick look at the init command. So this is below network. Here it is. So basically here we have a number of variables. So we have mnemonics for some accounts. So we have a demo wallet. We have some validators that we're going to set up. We also have some accounts for our relayers. All the different ports, but like I said, we're not going to go too much into detail. That's out of the scope of this presentation. But as you can see, what we do here is we remove previous data, we initialize the chains, adding Genesis accounts, creating and collecting Genesis transactions to make sure that our validators that we will need have some stake delegated to them. And then we're just going to make sure that all of the defaults in the configs are being changed and that we have everything set up to have our particular setup. Here on the bottom, this is also important. This will be for Interchain accounts, but we'll come back to that later. And then the start command, or the start script rather, is simply starting our binaries. And as we see that everything has worked out here, we can now trust that we have 2 chains running in the background, and we can go on to the next step. So here, this is just like to see the situation that we had before, make init. So basically, we had the code in our repo ready, but the chains were not built. This is why they have like the dotted lines. After we had this command, make init finished, we now have the chains that are ready. But to use IBC, we still need to make sure that we have our connections, well, actually our clients, connections, and our channels set up. But before that, we will also make sure that our relayers are configured. And so we have both commands. Now, in this demo, we'll be using both relayers. So we'll be using both of those commands. If you prefer one relayer over another, then you could decide, for example, to use only Hermes. An important addition to that is that right now in the version that we're using, version 2, the release candidate 3. Interchain account support was not yet added in the Golang relayer, but I think the version that was released yesterday, the release candidate 4, should include it, but I haven't been able to test it yet. All right. So this initialization of the Hermes relayer, essentially what it's doing, as you can see, it is setting up keys. So just that we have keys set up for our relayer accounts. So if we need to submit messages with our relayer, that they have an account that is also funded. We can also take a look here in the repo below network. Network is actually the only folder that we will be using often in the demo. So if we look at Hermes, we see here that we have the config.toml. And essentially for all relayers, what is important is that we set up the config for Hermes. For example, what you can do is you can go to the Hermes website. And on the Hermes website, you will find some information on the installation. If you had some issues of installing. And then also we have the configuration and an example configuration file, which has also a lot of comments on what the different parameters are. But so for Hermes, it's important that you copy-paste this file and make sure that if we have our chains here below, this is the most important thing, that we have everything that is correctly filled in. So here we see that our chain ID is HackATOM for one chain, Seoul for the other chain, and then some other ones that are important are the RPC and gRPC ports, and also the WebSocket, and some other parameters. Key name, for example, is also important. This is the key that we just set up in the make init Hermes relayer script. And this is what we do for Hermes. And then we have a similar thing for the Golang relayer. And actually in this script for the Golang relayer, let's look at it for a second. Should be this one. Here we will actually have the command relay config init. And essentially what that does is it creates the configuration file for you if you haven't got one yet. So the default folder is in your home directory with .relayer. But here actually we are using a custom home folder. So oftentimes when you are developing yourself, you may want to choose this option just so that you don't clutter your main configuration file. Especially if you're testing locally like we are doing now in the demo, it could be very useful to have a custom configuration file and then use your main configuration file if you're relaying on mainnet. And as you can see, we have initializing, adding configurations for both the chains and some paths. And then restoring accounts, again, is making sure that we have our relayer accounts funded and with the keys attached. All right, so then we can go back to the demo repo and look at the next step. So as you can see here, the next step is to create a connection between both chains. So this is the IBC part. And we're also going to create a channel that is for ICS-20 transfers. And so when we have one of those two commands, it's important that you don't do both, because then we will have two separate connections and two separate ICS-20 channels. And so for this demo, we're going to use the Golang relayer for the first part. So we're going to execute this command. So So we have make setup Golang relayer. And so this is going to go through the steps. So here we see, for example, already a client created. So it's going to create some IBC Lite clients on the chain. So we have clients created. What else can we see? The next thing when we have our clients created is the connections. So they're on top of the clients. Connections, they have a handshake. Let's see if we can find some information. Something to note here is that this could be a little confusing in that you have a lot of errors, but that doesn't necessarily mean that there are in fact errors. Sometimes it's just that we are querying for packets, for example, and that it's not finding packets just because there aren't any. So don't be fooled by that. Actually, what we can do is when you have this set up, so the script has finished, and now we can actually check if we have the required connections and channel. So by the way, I have a tab here for a relayer. I also have two tabs for the controller chain and for the host chain. So controller chain is HackATOM, host chain is Seoul, and a separate terminal tab for the relayer. And so this will be like very important, is that when you have the binary that you can use the help function. And actually when you go and look at the repo for the Golang relayer, here it is, you will see that they have some documentation, but they do say that it's probably better to look directly at the help, and then you will see the available commands. So we have something to set up the config, which we already did, chains, path, keys, but we can also query. So what we're trying to do right now is we're trying to query for the connection and the channels to see if they have been correctly set up. So there we see that, for example, we have relay query clients, but clients created this we got, so let's try connections. And so I'm first going to try it like this, but this is going to give a mistake. And the reason why is because we have chosen a custom home directory for our configuration file. So this we also need to give into the command line. And if you have JQ installed, this is a tool that will output the information in JSON format, which is a little bit nicer to read. Let's see. Looks like we still, oh yeah, we forgot the chain. All right, so it's important that you also tell on which chain you want to look for connections. We can do this on both chains. I've now done it for HackATOM. And here we see indeed that we have a connection ID, connection 0. So in fact, our connection has been established. Some more information you see here is that our connection builds on top of a client. So we can see the client, so it's going to be a Tendermint client, and it's ID 0. We have some version information, the state. So our connection handshake is essentially going to finish with both connection ends in the open state, and then we have some information about the counterparty. And then we're going to do a similar thing, but this time for channels to see if our channel has been correctly set up. And there we see that we also have a channel. So here we see some information. It's an unordered channel. So token transfer channels are unordered. Channel is open. Port ID is transfer. So we're working with ICS-20 token transfers. Okay, so that looks good to go. When we go back to the repo, then we can start the fungible token transfer part. And first thing that we're going to do here, this is just to make our lives a little bit easier. These are two commands that are going to export some environment variables. These are the demo wallets. So on each chain, we're going to have a demo wallet that has some funds attached to it that we can use. All right. And it's important if you do this that you pretty much do it in each of the different tabs. Now for me, this should already be fine because I did this in the preparation, but let's just do it again just to be sure. There we go. And then we can go to the first transaction. So now we have set up the client connection and the channel for transfer. We can go ahead and take a look at the actual command. So here we see we have the binary, TX, IBC transfer, it's a lot of transfers. But the way that you would go about it, if you're unsure what the command is, you could so you could go and check also with the help command, and then for example you will see transaction and basically do the different steps until you find this command. Let's copy it. And actually we want to send some tokens from the host chains from Seoul to HackATOM. So this is this terminal command. It's actually not really necessary to have the correct tab, because ultimately here we have the node which we are specifying, right? So even if we were to submit this command in the different tab, it would still work, but I think it's just like easier to follow if you do it in the correct tab. So now we're going to send this command where we are sending, I think it's 11,000 stake, which we're sending from the demo wallet 2 on the Seoul chain to the demo wallet 1 on the HackATOM chain. All right, and actually I noticed that I forgot to spin up my relayer, which obviously we need to do. Oh, and by the way, I see that I didn't add this in the repo, so this is something we should do. Oh, and actually I started the Hermes relayer. I meant to start the Golang relayer, but both will work. All right, so here we see that some packet has been sent. I think the timeout is set at 1 minute, so we were just in time to make sure that there was no timeout. And now we can check if we have received our funds by using this command. So this is just a query to see if what funds are available in the demo wallet. This is on the controller chain. And here we see that we have 11,000. And what we see here is actually not the stake. So we sent 11,000 stake from the host chain. But what we see here is, like I said, it's an IBC voucher. And this is a representation of the 11,000 stake, but on chain Seoul. And because this is obviously not super easy to read, we also have a command that allows you to have this hash and actually reverse it and give you the regular output. So this is the command denom trace, and we can do this on the HackATOM chain. So query IBC transfer denom trace, and then you just submit the hash. So IBC here is just a prepend to clarify to people that this is an IBC asset. And if we put enter, then we see that we have the base denom, which was the stake that was used on the host chain, on the Seoul chain. And then we have some path information, like we said. This has the port, which is transfer, and then the channel 0. And basically, this uniquely identifies, because our channel goes from the Seoul chain to the HackATOM chain. So this uniquely identifies the IBC asset. All right, so now we have some assets on the controller chain from the host chain. And this will set us up for, we can probably kill this for a minute. And this will set us up for the second part, which is interchain accounts. But first we'll go back to the presentation for that. All right, so token transfers we have now seen in action and seen that it works. And token transfer is an important first step, but of course, like we mentioned in the introduction, with IBC we can send arbitrary data, so we don't just want to send some tokens, we also want some more customizable application logic. And so you could do this in 2 different ways at the time. So we have interchain accounts and custom IBC applications, and we're kind of going to take a look at what the difference is between both and why you would use one or maybe the other. So let's start off with custom IBC applications. So essentially, this is a module, an IBC module that you build from scratch yourself. So in the documentation, we could take a look at this. So here we have the IBC Go documentation. Here, applications. This will basically go over all the different things that you have to do to build an IBC application module. So we have to implement IBC module interface. So this will have some channel opening, handshake callbacks, channel closing handshake callbacks, packet callbacks. It will bind to a port, like the transfer port that we saw with token transfer, adding keeper methods, and so on. So basically, this should give you an overview of all the things that you need to implement to have an IBC module. And then, of course, what you will need to do is add your specific application logic. So this is basically like a completely customizable way of developing application modules. So here we see that we have a module that we build. We can send pretty much any data that we want. Then it goes to the corresponding module on the counterparty. And what we see here on top is that we have ICS-X. For example, token transfer was ICS-20, so the number actually defines a particular application. Now, the thing is, when we develop these applications, like it takes a lot of development effort. Also, it will take some time for it to get standardized. For example, recently we had the ICS-721, which implements the spec and the implementation of interchain NFTs. But this, takes some time to develop. And if you want a lot of customizability in the application logic, this may be the way to go. But if what you need is something else, you could also use interchain accounts. So what interchain accounts allows you is basically to use functionality on the host chain. So here this is chain B, to be used by a module or an account on chain A, which is the controller chain. So I like to think of it as pretty much an API. So for example, say that we are developers on chain A, and we are developing some type of module. And during this module, during our execution of the logic, we would need some functionality that is present not on our chain, but on chain B, for example. So what we can use interchain accounts for is basically to have a programmatic way to use this functionality on chain B without leaving the environment of our own chain A. So to make this a little bit more clear, we're going to take a look at the architecture. So once again, the different namings, like it's important to get some familiarity with that. So we have the host chain, which is the chain that will host the Interchain account, and then we have the controller chain. So the controller chain is the chain that will trigger the actions to be executed on the host chain. Once again, you can think of it like an API. And then these two things we'll take a closer look at in the next picture. But what is important to notice is that as a chain you could choose to implement both host and controller functionality, or you could simply choose to implement one of each, right? So you have the choice in that. And actually what we've seen up until today is that most chains have, or a lot of chains actually have had this host functionality included, but not yet controller functionality. And we'll take a look at why this is. So here we see another diagram. So again, on the left we have the controller chain, on the right we have the host chain. So what is happening, this is for actually already an execution of a transaction. First thing actually is that we need to register this Interchain account. So when we see the two main functionalities of Interchain accounts, this is register Interchain account, and then we can send a transaction. But the important thing here is that on the controller chain, ICS27, the module that is present in IBC Go, implements this, and this actually works as middleware, but this has to have an authentication module that basically has to be built customly by the developers. And that's why we think that, up until now there's not so much adoption of controller chain, because chains will have to figure out how to build the authentication module. And again, we have in our docs like step-by-step guides on how to do it, but still it takes a little bit more time. But basically when we have this, we can wrap the middleware around, and then we can go to the other chain where we will route the transactions to be executed to the Interchain account. And the Interchain account, which is just actually a regular account, can submit the transaction on the host chain. Something important to notice here, and maybe this will be easier with this, is that the original intention of Interchain accounts was not to make sure that just any account on chain A could control an account on chain B, right? This is actually possible, and in the demo this is exactly what we're going to do. But this was not the intended use case of Interchain accounts. More so, it was the intention to have a chain itself, or a module on this chain, control an Interchain account on another chain, and so, again, to use it as an API. But still, there's a few different ways to do it, and we can take a look at this. So, first and foremost, the most simple is just single user. Every single user has one separate Interchain account. This is what we're going to do in the demo. And what is actually easy about this is that when we have this module with the two different functionalities, register Interchain account and send TX, in this case, you simply make sure that your authentication module exposes these two methods directly to the end user via the command line interface. And so a small variation on this is if the Interchain account is actually a contract, smart contract account, for example in CosmWasm. And then we have the more intended use cases of Interchain accounts, which we call few to one. So this is, for example, a DAO or a group. The groups and gov interface of the Cosmos SDK 046 will make this a lot easier, so we're already working to make sure that we can use this easier interface. But it will basically allow a group of users to control an Interchain account on another chain. And then we have the last one, which is many-to-one. So basically this is what we said before, that we have a module that we're building, and our users can interact with the module on our chain, and if necessary, our chain can trigger an Interchain account transaction on another chain. But as we said here, we're investigating if we can kind of have for each of these templates, if we can have some kind of a standard controller, which would actually limit the amount of development work that developers have to do to create their own custom authentication modules. And if we manage to do that, then yeah, probably we will have a lot more interchain accounts functionality out there in the wild. And I think I also believe that this is one of the challenges in the Juno track, which is basically to make sure that a COSM-WASM contract, which would be a module on the chain, is able to be like a standard for interchain accounts functionality. All right, and this sets us up for the second part of the demo. So let's go back. So first, before we start, a little summary of what we did. So the first thing we did, we transferred some tokens from the Seoul chain to the HackATOM chain. And right now I'm going to use the namings controller and host. So Seoul is our host and HackATOM is the controller. And like we said, what we wanted to do is that we want to do some transaction that will delegate some stake to the host, or to a validator rather, on the host chain without leaving the interface of the controller chain. So specifically for interchain accounts, we have this situation. So our demo repo, which is actually a fork of the interchain accounts demo. So you can check this out as well. It's actually pretty similar. I just changed some names. And here actually the Golang relayer doesn't really work yet. So it's better to like use the HackATOM demo repo. Where were we? Yes, right here. So essentially, this implements also the authentication module. And if you take a look at the code, if you are familiar with Cosmos SDK development, our modules are in the X folder. And here, InterTX is essentially the authentication module that we built for the demo repo. But once again, this is the quite simple implementation where we just expose the methods to the end user via the CLI. All right, so this is what I forgot the first time, so let's do this immediately. We're going to start the Hermes relayer. All right, so our relayer is set up. So when we think of IBC, what do we already have? We had our client set up, we had our connection set up. We also had a channel, but that was an ICS-20 channel. So remember I said that for each application, we need a different channel. So we don't really have a channel yet. But for interchain accounts, it's a little bit different because each interchain account that we create on the host chain will actually require a separate channel. And that's actually one of the reasons that initially we didn't think it would be a good idea to give every single user on the controller chain a separate interchain account on the host chain, because that could lead to like a lot of channels, which could be an issue for relayers, but hasn't been like tried. Maybe it's not that big of an issue. But the important thing to realize is that first we need to register our interchain account, and this will be with this command. So this is a section registering interchain account. And registering the interchain account is something that we want to do on the controller chain. So essentially what we want to do is we want to stay on the controller chain. So let's go over, copy the command, and let's take a quick look. So we see InterTX, which is our authentication module. This is what we're going to interact with. We have the register command, and then we have the different flags that we have to fill in. You can take a look at that in more detail later. But let's see. So we have submitted this transaction, and then we see when we go to the relayer tab that a lot of things are happening. And let's take a look. So we see channel handshake step completed. And indeed, this has been performed on the connection 0, which is exactly what we want. And here we can see, for example, that the port is ICA controller, and then we have the address of the interchain account. So in ICS-20 for token transfer, we basically have a symmetrical situation where the port will be the same transfer on each of the counterparties. For interchain accounts, it's a little bit different. So for interchain accounts, we have ICA controller dash and then the interchain account address as the port ID on the controller chain. And then on the host chain, we have the port ICA host without any added information. All right. So let's go back. So we have now hopefully created the interchain account. We're going to see by querying. So back on the controller chain, we're going to query interchain accounts. So this is just a regular query that looks at the interchain accounts that are present. And then we see indeed here interchain account address, which is this one. So that should work. And now, ultimately, our end goal is to use this interchain account to submit a staking delegation transaction. But of course, this is going to cost some funds, some gas. And this is actually the next step that we need to do, is essentially to fund the interchain account, and then we can go ahead and send our transaction. This step is just to make our lives a little bit easier, and we're going to export the ICA account address. So let's just do this in the 2 terminal tabs, just for safety. All right, so we've done this. As I said, next step is funding the interchain account wallet. We can just check. So if we check on the host chain, which is where the interchain account is located, we're going to check for the balance of the interchain account address. This should be 0 because we just created it. And in fact, we see that there is no balance yet. And then we have 2 ways of funding this interchain account. One way, which is just a regular bank send on the host chain. This is what the original interchain accounts demo uses, but I thought it would be more interesting to use actually interchain token transfers. So essentially what we're trying to do here is, for example, if you had the native token of the host chain already available on the controller chain. So for example, this could be that you go to Osmosis and you make a swap, and you actually have the native token from the Soul chain without actually ever interacting with the Soul chain. And you have this. We could take another look at the balance. Let's see if we have one here. I think it was this one. So again, just a little reminder, the balance of our demo wallet on the controller chain is essentially these 11,000 and the IBC voucher. And what we're going to do next is we're just going to send a part of that to the interchain account address via an ICS-20 transaction, and then we can use our funded interchain account. All right, here we were. So this is our command for the IBC transfer. Again, we are on the controller chain. So IBC transfer, transfer channel 0. We have the interchain account address, that is the recipient, and we're going to send over 9,000 of our 11,000 funds. And then we just have the regular flags. let's take a look if our relayer is running, and yes, it is. So if we perform this, we can take a look. Yeah, something seems to be happening. Always takes a while, but it doesn't actually take that long, so we should be fine. And if we check now again for the balance of the Interchain account address, it should be funded, and indeed it is. And we see that we have our original denom back, which is just a native stake, and we have 9,000 of this. So, okay, this is now our situation. So we have the controller chain, host chain, we have our Interchain account that has some funds attached to it. And the next step is going to be that we want to stake some of these funds to one particular validator. And this is the next part. So here we see that we can send Interchain accounts transactions using the InterTX, which is our authentication module, and then submit. And yeah, we have the example of a staking delegation. So this command first is just to find a validator address on chain, on the host chain, on Seoul chain. So here we have the validator address. And then this is actually the Interchain account transaction. And so basically what we submit here, as you can see, is the transaction data. So this is what is going to be inside the packet, and then on the host chain, this packet is going to be decoded, and we can simply submit this transaction on the host chain. So let's copy this, and let's go to the terminal again. So again, still on the controller chain, haven't left this interface, and we can submit this. Let's check again. Relay is still running, so that's fine. And let's submit this. We see that something is happening. All right. So this should have worked, and now we should have some stake delegated to this particular validator. And by the way, there's also an alternative way to do this. If you don't want to add this to the command line interface, we can also have a path to a JSON file that essentially includes the same information. Yeah, it tells us to wait until the relayer has relayed the packet, and then we can check with the query of the staking delegations for the validator address. So this is going to be on the host chain. Oh, and by the way, I should mention that we staked 3,000 stake. And here we see this. So this huge amount of stake is essentially created in the Genesis transaction, and then here we see the 3,000, which we have just delegated ourselves. All right. So yeah, this is the end situation where we effectively delegated some stake from the controller chain without leaving this interface to the host chain. So let's do a little recap of what we did until now. So we first sent over some tokens from the Seoul chain to the HackATOM chain. Basically, this is a step we do in the demo, but ideally the scenario is that you don't actually have to interact with the host chain. You simply interact with the controller chain, which is what we did. So again, if you want Interchain accounts, first you need to register your Interchain account, and then you can use the transactions. Those are basically the two functionalities. And the next thing that we will have in the demo is a timeout scenario, but let's first go back to the presentation and talk a little bit about this. So remember that earlier in the presentation I gave you this packet flow for the happy case. But of course, not all cases are happy, and sometimes we have something that happens, and here we see that the relayer, for some reason or another, maybe they were online, maybe something else happened, but for some reason they did not pick up the packet. And so when we don't pick up the packet, Obviously, we don't want our packet, especially when there are funds attached to it, we don't want our tokens, for example, to be locked up indefinitely. So that's why we have some kind of a timeout functionality. And what we see here is the query non-receipt. So the cool thing about IBC is that we cannot simply query to see if we had a receipt of our packet, of our token, but we can also query for non-receipt. So if the timeout period has passed, we can use this query non-receipt, and if that comes out positively, then we can submit on the source chain a timeout packet command or message, and then yeah, some application logic can be used to revert the original send packet logic that was executed. So for example, when we have token transfer, that would just mean that the locked tokens are being unescrowed again, and you can use them again, maybe like send another transaction, or just keep them on your account on the source chain. But yeah, this is basically the timeout functionality. And something that is important to note for interchain accounts specifically is that interchain accounts have ordered channels. And the case is, in an ordered channel, if we have a timeout, basically that means that a packet got lost, and because we have ordered channels and every packet needs to arrive in order, this will lead to problems, and this is why in ordered channels, if we have a timeout, the channel is closed automatically. And so this is another situation that we're going to look at in the demo. So here we are. So we are going to test the timeout scenario, so this will require some coordination on our part, because as of right now, my relayer is still running. So to make sure that we can test this timeout functionality, it's important that we shut off the relayer for a bit. So now, essentially, we don't have another relayer running. So if I were to send a packet, this packet will not be picked up. And the channel that we have created will be closing. So here it says, first step, stop the Hermes relayer, as we did. We should wait for approximately 1 minute because the timeout period has been set to 1 minute here. Oh yeah, and in the first step it also said to send another staking delegation transaction. So let's do this. This is this command again. So back on the controller chain. So we said 3,000. That's not enough delegation. We actually want to make it 6,000. So we're going to try this. But obviously our relayer is not running, so it cannot be picked up. Let's see, let's wait 1 minute. And so while we're waiting, I'm already going to go through the next steps. The next steps, after we've waited enough, more than 1 minute, is to start up the relayer again. And when we see this, we will observe that the relayer is taking care of the unrelayed packets. So when you start up the Hermes relayer, it will look if there's any unrelayed packets that it needs to take care of. It's not just going to start listening to packets, but forget about those that it didn't pick up. All right, so I think that should be fine. Let's wait 30 more seconds. And the next things that we're going to do is we're going to check if indeed our channel state has gone to closed, as you can see here. So obviously if our program works correctly, or if the IBC protocol works correctly, this is an order channel with interchain accounts, and so it should be closed. All right, I think we waited long enough. So here we go. Let's start up the relayer again. And here we go. So yeah, you'll have to learn a little bit how to read these debugging tools. But here we see, or the logging tools rather. Here we see they extracted a timeout packet event. So indeed, when starting up the relayer, it looked for the packets, saw that the timeout period had passed, and yeah, they submitted a timeout to the original chain. All right. And so the next step, as we said, was to check if our channels had been closed. Now, remember, at first we did this actually with the relayer software, but we can also just do this with the chain binary. So let's check it first on the controller chain. So we're going to query the IBC channels, and let's take a look. So we have our channel ID, channel 0. Remember, we also made a Interchain token transfer channel, so this is actually the channel 0. This should still be open. So even if we had sent another token transfer transaction, this channel would not have closed because token transfer channels are unordered, so it doesn't really matter if there's a timeout from a packet, everything can still go on. So this was our channel 0, and then we should also have a channel 1. There it is, it's on top. The channel 1, and this one says indeed that it is closed. All right, so the IBC protocol did its job. And yeah, we're also going to look on the counterparty chain. There we go. So here we see the same thing, channel ID, channel 1 is closed, and channel 0 should still be open. There we go. All right, but of course, if your channel has been closed, that doesn't mean that you can't use Interchain accounts, transactions anymore. So next step would just be to register another Interchain account. So again, on the controller chain, we have this command, intertx register, and we're simply going to create a new Interchain account, which will use a new channel. All right, yeah. So the relayer was still running. And so if we go back to the previous command, so again, we're going to query the channels. So now we see we have channel 0, we have channel 1, the ordering is a bit off, and then we have this new channel, channel 2, which is our, here we go, port ID is ICA controller, and then the Interchain account address, and then we see counterparty ICA host, so this is clearly ICA host, ICA controller, and then the address, whereas, as I said before, for channel 0, token transfer is just port ID transfer, and counterparty port ID is also transfer. All right, and I think, yeah, we're not going to send another transaction, but actually we could just to check if everything goes as planned. Right. So now we do have our relayer running, and we're going to try again to send an additional 3,000 delegation to our validator. All right, seems to have picked up the packet. And then we can check again the staking delegations, and now we have 6,000. All right, so this worked. And I think that's it for the demo. I think we still have some time, so what I'm going to do is I'm going to maybe take a look at the Hermes help command. So yeah, essentially I was explaining that it's probably a good idea to play a little bit with these commands, use the help. So for example, say I want to create something, I can do Hermes create and then help. Say we want to create a new connection. right? And so there we then see Hermes create connection, we have some options, and we need to make sure that we have as a arguments the chain AID and the chain BID. And so for each of the different things, you will find some explanation here and all of the arguments, all the flags that you need or that are optional. So essentially this is what you could be doing. Some other sources maybe to go through. Okay, this was the demo. So again, the documentation from IBC. So if you want to write your own custom IBC applications, this is where you go. First you have an overview. Let's see if this loads. Yes, there we go. So this is a high-level overview, essentially what we did today. So we have applications, as I said, middleware. So this could also be an important thing. If we have some functionality that doesn't really go in IBC core, we could use this as middleware and basically reuse it for different applications. So we could actually build an entire middleware stack. I don't think the picture has been added, but I should have it here. Yeah, so basically what we see here is that we have the base application and then we can have middleware 1, middleware 2, but essentially we can keep on stacking the middleware and create functionality that way. And so here we have then on top core IBC, and so for example the messages packet and write ACK are going from base application to core IBC, and when we have handshake setups, ACKs and timeouts, the communication actually goes from core IBC through all of the middleware to the base application. And so what you can see here is that the order matters. So if you have a particular order on one chain, for example, make sure that the order is the same on the counterparty chain. All right, what else do we have? Upgrades. So this is also an important aspect. So because we have the entire ecosystem or the interchain, which all have IBC, if we want to upgrade both our chain or the IBC version, this is not something that you can just do because we have our light clients that are depending on the information that you have, and so if you perform an upgrade, you might want to plan this and make sure that the relayers can send the appropriate messages to make this a coordinated upgrade so that we can keep our light clients and basically can keep the channels functioning. We also have governance proposals. So for example, if a light client could get frozen, this could be because there was some misbehavior, or it could be because there was not enough activity. So basically, the light client that we have on chain for another chain, it needs to be updated with some information. And so if there's not a lot of activity between a channel, between two chains, we don't really get that update client information. And so usually what relayers do is they make sure that periodically, even if there is no activity, they're going to send an update client message just so that everything keeps running. We also have a trusting period, and if it so happens for any reason that the relayer is not updating the client for longer than the trusting period, the light client could get frozen. And then we have governance proposals to unfreeze the light client. Relayer doesn't really have that much information. It's actually better to go to the Hermes documentation or to the GitHub repo of the Golang relayer. Then we also have a section for the IBC application modules, interchain accounts, interchain transfer, token transfer. We have fee middleware. This is a new thing. So we haven't seen a lot of implementation with that, but you could go ahead and familiarize yourself with it. And then also migrations for going to a different IBC version. And then we also have the Cosmos developer portal, which we talked about already. So there you have some tutorials, some articles, but mainly we here have the Cosmos Academy. So if we take a look, all right. So here we see a general introduction to Cosmos, main concepts, running your own Cosmos chain. So I think here basically, yeah, you work with Ignite CLI, and you're basically going to create your own chain. The example that is here being used is a checkers blockchain, so you can play the game of checkers, but hosted on the blockchain. And then here, if you're only interested in IBC, we have also a section on IBC. So we have the overview, general introduction to IBC, what is it? And then we have the different aspects or the different abstraction layers of the transport layer. So we have clients, connections, channels again. Also some applications, so fungible token transfer, interchain accounts, relaying. So if you need some more background information on relaying, you can also find it here. So first we have some general information, then the Go relayer. Maybe if you go to this today, like I said in the introduction, there have been some upgrades for the Go relayer, so and also actually for the Hermes relayer, so we're going to have to review this information. But yeah, in general, the information also about the config file and what you need to add is there. And then last we have some IBC tooling. So map of zones is an interesting one. Basically you have this nice overview here of all the chains that are being connected, which is kind of nice. The next one is MinScan. So we have MinScan also now with the nice visualization of all of the chains that are connected and all of the IBC transactions that are happening. So yeah, MinScan, map of zones are good sources to find some information about IBC in particular, but also about regular transactions. And then we also have IOB scan. IOB scan is still in development, but it has improved quite a bit already. And so this is one that is really like focused also on IBC. I do see that this link is not working. We should look into that. So that's the IBC information in the Cosmos Academy. Like I mentioned before, the same topics will be in the Interchain Developer Academy. If you wish to apply to that, there's still time to apply for the September cohort. So this is the Hermes documentation, which we already went through. This is the HackATOM path. All right, and then a few more words on what to do next. So, as I already mentioned, if you're interested to learn further about IBC or the bigger Cosmos stack, go to the Cosmos Developer Portal, maybe sign up for the Interchain Developer Academy. Basically, the advantage of the Interchain Developer Academy is that you are guided and you also have like some exams, some quizzes. So if you need some accountability to, for your learning, then this might be a good option. You do need like some time, I think it's like 10 hours per week for 6 weeks long that we ask for people to spend on this. Another thing that you could be doing based on the demo of today is to build some custom authentication modules. So what it could be either the standard based on these templates. So for either of these sections is something you could be doing. You could build your custom IBC application. So again, in the documentation you should find all of the necessary steps, and then you can add your custom logic. Also two other things, interchain security will be really, really nice, and there's actually a workshop today. I'm not sure if it's still at 2 p.m., could be a bit later, but it's by Dan from Informal. Also interchain Cosm wasn't contracts. I think also the next talk, next workshop will be about IBC contracts. And there's still a lot to do in the Cosmos ecosystem. So yeah, I think if you want to develop, that you'll have no shortage of tracks to go. And I think that's the end of the presentation. Yeah, there's some time for questions. First and foremost, thank you for your attention. And yeah, good luck in the hackathon, and hope you build great things. Thank you. Are there any questions? Yes? Sorry? Yes, I do think there's some ideas for some pruning later, but I don't think we do that right now. Someone else? Yes? Is middleware on the packet level, or is it on the higher level message? Middleware is more on the application level, yeah. So, so essentially, this is also maybe interesting. In middleware, we could also like manipulate, for example, the packet data. So some examples that have been talked about are like, some filtering. Maybe like manipulating the packet data in middleware is a little less interesting. But yeah, like I said, if you have an application for it, there's a lot of freedom to use it whichever way you want. Yeah, you had another question? So even in unordered channels, we have like a sequence number, but it means that the sequence numbers don't have to like arrive in sequence. So there's still a sequence number. I'm not actually sure what it's being used for, but yeah, in ordered channels, it's basically the packets have to arrive in a certain order, and if that's not the case, then we time out the channel. There's also work on partially ordered channels, but that will probably be for Q4 of this year or later. Sure. Feel free.
Sorry, I just want to answer that a little more. I'm giving the next talk, and it's a very good question. Sorry. Unordered channels are basically like UDP. The packets arrive, and you're only guaranteed timeout or arrival. Ordered channels are like TCP, you're guaranteed in order, right? That's really the kind of the equivalent there. The one key point this is, in an unordered channel, any packet could time out, right? So you do 5 packets. Number 1 is relayed, then number 4, then number 2, and then 5 and 3 never deliver, they're timed out. Then 6 comes later, doesn't matter. With you don't have any guarantees if you send multiple packets at once. If you have an ordered channel, you're guaranteed if you send 1, 2, 3, 1, 2, 3 will arrive. If there's any of them times out, the channel gets closed. It's actually pretty strict, meaning it's impossible for a relayer to trick you and, okay, I'll just like drop one of those packets and run the other ones. So you have guarantee you can send 3 or 4 packets in a row and you guarantee them arrive in that same order. And it's very important for that. It's a little more fragile, it's very, very strict.
Thank you. Any more questions? All right. If not, I just want to say that I'll be here the rest of the day, so if you're interested in following the interoperability track, feel free to reach out to me and we'll look at your question, even if it's about the documentation or about the specific workshop. And once again, thank you everyone, and yeah, have a great rest of the day. Thank you.